Well, hello everyone. I'm J.D. Harrington, Public Affairs Officer for NASA's Aeronautics Research Mission Directorate and headquarters here in D.C. I'd like to welcome you to today's news conference. We'll talk about NASA Aeronautics Research Portfolio. We'll talk about the President's Fiscal Year 2017 budget, plus what that enables us to do over the next 10 years. We have also a special announcement that we're kind of excited about. We also have three panelists that are going to join us today. Each one will give brief remarks. We'll give the announcement that we just talked about, and then we'll open up to question and answers. This presentation will last no more than an hour. Today's panelists include Charlie Bolden, NASA Administrator from NASA headquarters in Washington, D.C. We also have Jaiwon Shin, the Associate Administrator of NASA's Aeronautics Research Mission Directorate, also in D.C., as well as David Melcher, President and Chief Executive Officer of the Aerospace Industries Association out of Arlington, Virginia. And with that, we'll call up Charlie. Charlie?
First of all, let me thank all of you for coming out, particularly our industry partners and friends. I had a chance to meet some that I have not had an opportunity to meet before, so hopefully we will get to see a lot more of each other. And for those of you from the media, just come on up and feel free to ask questions later, not right now. I do want to say how happy I am to be here. I don't think there's a better place, a better venue than to be right here at Reagan National Airport today for what we're about to talk about. Personally, I love leap years, and since this is leap day, I think the reason I like leap years so much is because NASA's always talking about taking giant leaps to benefit humankind. So what a more appropriate day than leap day of leap year to talk about what we're going to talk about today. I think some of you who have heard me before know that I'm a big person when it comes to talking about the first A in NASA, and I call it the big A in NASA. Our heritage is aviation and aeronautics. And sometimes people forget that in the hubbub of always talking about human space flight and our incredible science advancements, but we really want to have everybody focus today on the heart and soul of what NASA's heritage is, and that's aviation. I truly believe that 2016 is going to be a tremendous year for giant leaps, and I say this in terms of aviation, which we're here to discuss today, as well as space exploration and our journey to Mars, but we're not gonna talk about that today. I'm joined today by Dr. Jaiwon Shin, NASA's Associate Administrator for Aeronautics Research, and by David Melcher, the CEO of Aerospace Industries Association, or AIA. We're here today to talk about NASA's work to make flight cleaner, greener, safer, and quieter, all while developing aircraft that travel faster and building an aviation system that operates more efficiently. There's a certain excitement about being able to discuss the future of flight with this wonderful airport, DCA, as a backdrop. People from all walks of life and all corners of the globe surround us as they head down to the security gate. And I told them when we were walking up, I said, well, I sure hope you haven't put us in line with the security gates, because the last thing we want to do on this big day is to have people go wherever they're going and complain about NASA blocking traffic. So I'm glad to see we're down in a nice, safe corner. Every time the folk here with us today take off and land, they're contributing to some 1.5 trillion, and that's trillion with a T, in economic activity that's fueled by American aviation. Of course, each takeoff and landing represents more than just dollars and cents. It represents families with food on the table, thanks to the 12 million jobs supported by American aviation. It represents businesses connecting with businesses in a world that's growing smaller and smaller by the day, thanks to aviation. It represents old friends being reunited, and as a grandparent, that means grandparents like me attending the wedding of a grandchild, a patient waiting an organ, an entrepreneur shipping out the very first batch of new products, scientists traveling to collaborate, and diplomats, especially from this place, working to bring peace to our troubled world. With so much riding on the wings of our aircraft, we at NASA take our responsibility very seriously. I am so proud of our employees, contractors, and partners whose work is why we're able to say with all sincerity, NASA is with you when you fly. They and their predecessors are the reason why every U.S. aircraft and U.S. air traffic control tower has NASA-developed technologies on board. Now, I'm not the only one who has a lot of faith in the ingenuity and ability of NASA people. President Barack Obama has made a very bold statement about the respect and belief he has in NASA's work. The president is calling for a new $3.7 billion investment in green aviation. That's in NASA, a $3.7 billion investment in green aviation, and that's over the next 10 years. That's in a very real sense, it's also an investment in each and every one of us. I would argue that every American is poised to benefit from some way in this investment, because all of us have a stake in breathing cleaner air or living in a country where more and more of our neighbors are working in stable, well-paying jobs. As our climate continues to change, we all have a stake in building a future where we fly on aircraft that consume half as much fuel, that generate only 1/4 of current emissions, and that make use of greener energy sources in the first place. With global air passenger traffic projected to double over the next couple decades, it's best for all of us that we find new ways to absorb billions of new passengers without compromising the safety of our skies. Every American has a stake in bringing about a future where our airports are better neighbors because aircraft operate as much as 42 decibels quieter, and therefore the noise at airports like DCA, IAD or Dulles, and BWI is contained within the airport's boundaries. A future where people can travel to most cities in the world in 6 hours or less in an airplane that flies faster than the speed of sound over land with hardly a hint of a sonic boom. If all this sounds like science fiction, well, that's why I like to say that the people of NASA turn science fiction into science fact, and that we make the impossible possible. The President's proposal would allow Team NASA to do just that, from aviation energy efficiency to a transformation of propulsion systems to improvements in aviation mobility. This investment will allow us to make giant new leaps. I'd be remiss if I didn't also mention that our researchers projected even before this investment that we could save the commercial airline industry as much as $255 billion, and that's with a B, billion, over 25 years through the green aviation technologies NASA is helping develop. Just think of what we'll be able to do for our economy with the additional resources the President is proposing. With this in mind, I want to highlight one of the exciting things that the President's proposal will allow us to propel forward: partnering with industry to build a series of experimental aircraft, or X-planes. And let me tell you, any of you have kids in college who want to be engineers, just out of curiosity? It is, for Jaiwon and me, who go to colleges and campuses around the country, this year has been incredibly rewarding to go to a place like Georgia Tech or MIT or the University of Maryland and be able to tell a young man or a young woman that they ought to think about coming into aeronautical engineering, because there is definitely a future there, because we're getting ready to do new and exciting things, and we can actually tell them that we're about to get more money into research on their campuses so that their professors can be involved in that research, and they have somebody to mentor them on real research, not just theoretical stuff, but on real research and building airplanes. And that's what I think is so exciting about the President's budget and the idea of NASA getting back into the X-plane business. Along these lines, I have an exciting announcement to make. Nearly 70 years since Chuck Yeager broke the sound barrier in the Bell X-1 as part of the NACA's high-speed research, today, NASA is awarding a $20 million preliminary design contract for a low-boom flight demonstrator aircraft to a team led by the Lockheed Martin Aeronautics Company in California, which also includes GE Aviation in Ohio and Tri-Models Incorporated, also in the Golden State. This first X-plane will be called Quest, for Quiet Supersonic Technology. And here's the magical part. The design is for a piloted test aircraft that can fly at supersonic speeds but create a sonic boom that's more like a soft thump instead of the annoying boom that currently prohibits commercial supersonic flight over land. In scientific and technical terms, I think that's what they call a big deal. So I'm excited. And perhaps the best news of all is that this is just the beginning. So, with that in mind, I'm going to ask Dave Melcher and Jaiwon Shin to come up and help me unveil an artist rendering of the low boom supersonic demonstrator. And then I will turn the podium over to Dr. Shin, who's going to give you real details about what we're talking about. So Jaiwon and David. There we go. You want to be the center guy?
I'll be over here to support.
I think we just fold it back. Is that the safest way to do it?
Great, thank you so much, Charlie. And I want to also add my welcome to everyone who took a time out of busy schedule and be here. For people like me who really loves airplane, this is home. This is a beautiful airport, and I'm glad there are some airplanes in the background. But again, I want to thank my boss, Administrator Charlie Bolden, for the amazing, exciting remarks. And good afternoon, ladies and gentlemen. And I want to congratulate Lockheed Martin for this award. And NASA looks forward to working with Lockheed Martin to achieve a successful preliminary design of the world's first quiet supersonic X-plane. And you saw the concept there. And just imagine several years down the road, that picture there starts flying over Chicago and Los Angeles, and then people can, and hopefully people cannot hear or didn't even know that supersonic airplane just flew by over their heads. That's the objective. So I'm honored and privileged to represent the hardworking men and women of the NASA Aeronautics family, and also our partners in industry, academia, and government. NASA has made significant contributions to aviation, and as you can see out the window, I'm glad that all of the airplanes out there actually have winglets, that small spike piece at the tip of the wing that reduce the drag and save fuels. That winglet came from NASA many years ago. So that's just one very visible example of NASA's contribution. And in 2013, Administrator Bolden announced our new and exciting vision and strategy for NASA Aeronautics to ensure the next 100 years of research excellence, as we have been doing for the past 100 years from NACA days through NASA, as well as help maintain U.S. global leadership in aerospace industry in the face of growing international competition and support aviation's key role in our nation's economy. As a bold step in advancing this vision, the President has requested $10.6 billion over next 10 years for NASA Aeronautics, and that is that $3.7 billion increase that Charlie mentioned, and starting with $790 million in FY17. So I would say we are at the right place, at the right time, with the right technologies. This 10-year budget plan will allow us to accelerate our work to transform aviation, to achieve revolutionary breakthroughs in aircraft and also air traffic management technologies, and improve aviation's efficiency and safety, while at the same time dramatically reducing fuel consumption, emissions, and noise. With this strong support, we'll be able to develop and demonstrate in flight a wide range of advanced technologies through a series of X-planes, as we are calling new aviation horizons. And this quest is one of those X-planes that we would like to design and build and fly. With what we learned from Quest, we can influence changing the current regulation that bans commercial supersonic flight over land. That is a very strict regulation, international standard, and we like to help U.S. industry open up an entirely new market that could mean additional high-paying and high-quality jobs. And there will be a series of subsonic demonstrators that will look very unconventional. And as you can see, some of the desktop models and 4-foot model here, if you have seen this kind of airplanes, just give us a call that I'd like to get on those airplanes now. But these are our concept airplanes that we've been working on many years. So as you can see, this is a complete departure from tube and wing, conventional tube and wing aircraft shape. So with what we learned from these subsonic demonstrators, we can achieve a future where commercial flight uses only half of the fuel that state-of-the-art aircraft uses now, and also a quarter of nitrogen oxide compared with today's state-of-the-art commercial airplane. And very importantly, for local community, this kind of technology will keep its takeoff and landing noise well within the boundary of the airport. We'll continue learning more about the benefits of using alternative jet fuels or engine combustors that can operate on more than one type of fuel, any kinds of alternative fuels or biofuels, or aircraft that are powered by hybrid electric systems. I like to use this analogy. If you look out the window, that marvelous modern engineering wonder that we call airplanes, with the new Aviation Horizons X-planes, we will free the beautiful butterfly stuck in that configuration, and we'll free that beautiful butterfly to fly greener, safer, and faster. We'll be able to achieve the full potential of revolutionary technologies and designs that lift aviation to the next level of flying greener, safer, quieter, and faster. And it will up the game to a completely new level. I mentioned our workforce at the beginning of my remarks. There's a very powerful human element in this ambitious 10 years plan as well. As Charlie also mentioned, just imagine how much inspiration we can bring to next generation of engineers and scientists as they watch these very unconventional looking X-planes flying around the country. In addition to new aviation horizons, the 10-year investment also will expand our ability to accelerate the safe and more efficient air traffic management that accommodate growing demand and growing variety of aircraft. Now, in closing, this opportunity didn't happen overnight. We're at this point today because we've made significant technical progress since 2008 timeframe. Administrator Bolden mentioned that commercial airlines could save over $200 billion in fuel consumption through 2050. That is the one clear example of NASA green aviation technologies that we have worked to benefit our nation's aviation industry and national economy. This kind of research result is a great example of what can be done when a robust government investment combined with a collaborative public-private partnership. And that's why I'm very thankful that I see many colleagues and friends from our industry partners present here today, because we couldn't have done this amazing advances of technology without industry partners. So this is our moonshot. NASA Aeronautics is ready and able to take on this exciting challenge on behalf of the nation and the flying public. We are indeed at the right place at the right time with the right technologies. So as I mentioned, public-private partnership is an essential part of our success. So I'm very pleased that Mr. David Melcher, President and CEO of Aviation Industries Association, is present with us. So, Mr. Melcher.
Well, I first want to say thank you to Administrator Bolden and Dr. Shin for having me here today. There's a lot to be excited about today, not only in the ideas that have been presented, but in the potential that they represent for the future. And ladies and gentlemen, I represent, as was mentioned, Aerospace Industries Association, which has been around 100 years in 2019 and was formed by Orville Wright and Glenn Curtis, and represents about 300 plus aerospace and defense companies. And I'm delighted to be here in order to support NASA's new 10-year plan to significantly boost national investments in cutting-edge technologies, which you've heard a bit about, and aeronautics research. And as Charlie said, and is often want to say, this is a big deal, and we ought to really care about it. You should make no mistake about it. When it comes to examples of public investments that set the gold standard for performance and public benefit, NASA's aeronautics research, in my mind, tops that list. It makes tremendous sense to continue making smart investments through NASA in aviation safety and mobility, energy efficiency, and advanced propulsion system transformation. This budget will allow those kind of investments to be made and will make our country better. Better for technology, better for industry, better for the flying public that we see around us. We have a tremendous aviation infrastructure today, but demand for aviation services continues to grow. One estimate alone estimates a near doubling in the amount of passengers that are traveling between now and 2034, up to 7 billion worldwide. And so I think it's really incumbent upon NASA, that has always been a partner in advancing aviation technologies, to be an important part of that future. Throughout NASA's history and that of its predecessor organization, founded 101 years ago, a little older than us, the National Advisory Committee for Aeronautics, the government has performed a vital role in advancing progress on complex issues like wind shear, icing, electronic controls in cockpits, and bringing unmanned aircraft systems into the airspace. You name it, NASA was and is integral to the technologies that have advanced in each one of these areas and to conquer complex and problematic issues. This research hasn't been done alone. It's been done with the active support and financial commitment from industry and has benefited the entire aviation community. Through NASA's exciting New Aviation Horizons initiative, the agency that pioneered hypersonic flight will help us aim at revolutionary, not evolutionary, changes in the way people fly around the world. One of our association's great member companies, Boeing, has a terrific advertisement playing in its centennial year that envisions passengers in the year 2116 circumnavigating the globe in 2 hours. With a strong commitment to this type of research going forward, I think it's only a question of how soon, not whether, this bold vision can be achieved. And I join also in congratulating Lockheed Martin and GE Aviation for the contract here to advance the low boom supersonic flight, because I think that's also a great accomplishment and will be a great contributor to our nation's commerce going forward. So NASA's 10-year aviation plan will build upon this great work. It will continue the kind of efforts that this nation ought to continue. And I always believe in the power of ideas, and budgets follow sometimes the power of ideas. These are powerful ideas that benefit not only the flying public, but also the technology that one would expect from American and American industry. And so I lend my full support to this. Our member companies will lend their full support to this. And I think that this is something that hopefully those of you in attendance and those on Capitol Hill will also realize is very important to our flying future. So thank you for allowing me to be here today.
Thank you, David. We're going to open up the question and answer session right now. We have a microphone here in the center of the room. We'd like media reporters to step up in an orderly fashion, identify themselves, their media affiliation, and if they could, tailor their question to a specific panelist so we know who they're asking their question of. And with that, we'll get started. Gentlemen?
Hi, this is Eric Nealer at Discovery News. I love airplanes, and this is wonderful. It looks like something out of Johnny Quest. What I'm curious about is how the flying public is going to benefit here. Flying is not a lot of fun. It's cramped, tired. It's a real challenge for a lot of passengers. So, granted, the airline industry is going to save a lot of money and get to fly faster, but how is the public going to benefit here?
I think if I give you the example of the 787, it's potentially not as cramped as most other airplanes are. The biggest benefit you get is that it's an all-composite airframe, which allows the airline companies to put more oxygen, more air into the cockpit. So most people who fly on a 787 recognize the fact that they're a little bit more rested when they get to their destinations as a result of having flown at a little bit lower altitude in the cockpit and also with more oxygen. So I think it's those kinds of things that we're endeavoring to bring to the flying public. Safer flight, faster flight, cleaner, more efficient flight, so that it makes it easier for them to get where they want to go a lot quicker and they have less time to worry about being cramped. Yeah.
Tracy Watson, USA Today, for the administrator first. What happens if Congress does not allocate you the money for this particular line item? Can you carry forward another way? And what kind of sound reduction will you achieve on the ground with this plane? Thanks.
Tracy, let me just give you one thing, and it's the way our government works. And you posed the great question, and the reason that we have been working diligently with the Congress since we rolled out the president's budget. I think everybody knows the saying is the president proposes and the Congress disposes. So as David said in his remarks, it is now up to the Congress to see the wisdom of what we have proposed and to see the benefit that this will bring to the flying public, to American industry, to the economy, just to the security of American citizens, because more and better jobs are available. So that's the key part, the key message that we're hoping that you all will help us get to the Congress. In terms of what we see as a level of dissipation of the spike, if you will, the amount of boom, we hope it'll be no boom, but a rumble. I'm going to see if Jaiwon or somebody else wants to try to give you something, but I think the short answer is that's why we're building a demonstrator. The theory says one thing. We want to see if it really works that way. You want to comment?
No, I think that's a really good point, Charlie, and I just want to add a couple other points that we are concentrating on X-planes for the purpose of this press conference. But we have been working on also a lot of air traffic management and safety technologies. As an example, we've been working with Charlotte Airport and also American Airlines and many other partners, close collaboration with FAA to improve surface management and also more efficient takeoff and landing processes around the very heavy and busy terminal area. So you earlier asked about the benefits to flying public. That type of research and technology transfer to airports and airlines will be able to certainly help on-time departure and also reduce the delays and the dreadful, you got to the airport 20 minutes earlier and your gate is not open, so you have to sit on tarmac for 20 minutes. We will eliminate those cumbersome practices. So that's one other part of aeronautics research, and with this funding increase, we'll be able to accelerate that kind of research as well. And in terms of aircraft capabilities, if you really think about this, again, bringing that butterfly out of the cocoon, then it provides a lot of flexibility for aircraft designers in the seating arrangement or the number of aisles and how to design the cabin. So I think all in all, that Charlie talked about that more oxygen pumped into fuselage today in 787. That's an immediate benefit from composite research that NASA has collaborated with industry. So now the next stage of opening up this configuration constraint, we believe we will make flight a lot more enjoyable. And because we can provide that flexibility and versatility for designers to free up their constraints. So in all sense, I think we can provide a lot more benefit to flying public.
Hi, I'm Mark Sellinger, Aerospace America magazine. Can you explain a little bit more about how you arrived at this particular concept and contract? Was there a competition, or is this an outgrowth of work that you've already been doing with Lockheed? And also, what's kind of the next step after they do the preliminary design? Are there options for additional contracts and activities? Thanks.
Okay, thanks for the question. So this so-called low boom design has been worked for many years. And actually, I want to introduce Peter Cohen, standing back there, tall guy. He's the project manager who's responsible for low boom research over the years. So this is by design. Design of the aircraft produces less intensity shock, so people on the ground will not be annoyed or bothered by boom level. So this is not through some gimmicky flight maneuvers or some artifacts hoping that we'll reduce sonic boom. So this is real science. But how we got here, Peter led his team for the, again, past several years, focusing on low boom research through ground testing and also working with the community to measure community's response. So we actually flew simulated boom generating flights and asked public on the ground, how did you feel about that, or did you sense that? And a lot of numerical analysis, so just tremendous amount of research has gone into that. And how did Lockheed Martin ended up winning the award? We certainly had an open competition, and the Lockheed Martin's design appeared to be the best value for the government. So that's why we selected Lockheed Martin, and again, congratulations on that award winning. But this is our strength of our industry, that we have worked with industry partners together to get here. And then when we send out that type of solicitation, our strong industry partners respond. And this is a marvelous design that one day will be able to open up to flying public to enjoy, again, supersonic flight. So just imagine, just one last comment, just imagine you go anywhere in the world, less than 6 hours flying a supersonic jetliner. And we owe to our children, the next generation, that type of a breakthrough from the aviation.
What's the schedule then for completing the preliminary design, and what comes after that?
Preliminary design will go on about 17 months, and then we'll go through another full and open competition and select the best industry partner, or perhaps partners. And then the design and build, actual detailed design and build phase, we are estimating about 4 to 5 years. And then we will go through flight tests to acquire the scientific data to work with the regulatory agencies after that.
Flight testing in the early 20s?
Yes.
And before you ask your question, stay right up there. I don't want to pass up the opportunity to thank David Melcher and AIA for all that they've done through the years. We keep talking about NASA industry or government industry partnership. That's really what we mean. I think 3 or 4 years ago, you didn't hear anybody talking about NASA's aeronautics budget. And it was not until, David's predecessor, Marion Blakey, and now David and AIA and our other industry partners began to talk to members of the Congress about the critical importance of getting up to speed so that we maintain our technological leadership in the world, in the field of aeronautics. It's one thing for us to say it. It's another thing for industry to go in and say, the ideas they have, they're really sound, and we can make it happen. And because we generally don't build. We come up with the concepts, and then we partner with industry because they're the ones that do the physical building and carry these concepts into reality. So I just wanted to say thanks for that.
Can I make a quick comment?
You sure can.
You know, speaking as a former CEO of an aerospace and defense company who came to AIA, you know, industry wants to invest in technologies for the future. But what industry is always looking for is a bit of a roadmap that tells you what is the target, where are we trying to go, what technologies are important. And so when you're deciding on how to invest in a company, you're not just throwing darts at a wall with no dartboard. You know, you want to understand, where does the nation want to go? Where would our investment potentially bring a return? And I'll take my hat off to NASA and Dr. Shin for creating a 10-year plan that has a ton of rigor to it, you know, that actually establishes those goals and those technologies that are desirable, and industry will follow and be great partners with the government when you have that kind of a plan, a very detailed, very well thought through one. And so I think that that's something to be congratulated.
Administrator. David Curley from ABC News. This is one project. It's a 10-year project. You have a longer vision. Actually, the poster here says it, what you expect flying to be like. Your grandchildren, what will flight be like for them on an aircraft?
You know how to ask me. I have 3 granddaughters. I am the very proud father of 3 beautiful granddaughters. My son lives in a house full of women. Even the dog's a girl. So he's in bad shape. You know, he's surrounded by women. But the middle granddaughter, the 13-year-old, wants to be a Marine Corps fighter pilot. And so what I see her flying is something that's going to be even more advanced than what we're working on today. It will be integrated with robotic systems. You know, she may be flying with an autonomous airplane on her wing, or she may be flying behind an autonomously powered or piloted vehicle. But that's the wave of the future. I really do see them flying on aircraft, like Jaiwon said, that can go any place in the world in under 6 hours. Going back to the question about what for the traveling public, or you were talking about comfort. Just think about it. When you're on a 13-hour trip, even the most comfortable airplanes that I've been in, it turns into an airplane after about 6 hours. So I think just by getting flight time down, it's like sending people to Mars. When we talk about that, the thing we want to do is make game-changing developments in in-space propulsion so we can shorten the time of transit, and that's what's really important. So I think we're going to find that my granddaughters are going places much faster. They're going places and much quieter for the public underneath and for the people in the airplane, much more comfortable where they arrive wherever their destination is, and they're feeling a lot better than sometimes they feel today. And then the other thing is, it's probably not going to cost a fortune, because we're really going to get the cost of flying down. That would be my ultimate hope also. Much greener, as a matter of fact. And we're already seeing that, you know, whether it's using newer types of fuels, biofuels, but also just in the engine design and in ensuring that what they put out is cleaner than what was put out last year. And each year is an incremental change, I hope.
Hi, my name is Julia
You can
Bacanio.
pull that down. Julia.
I'll just leave it. I don't want
That's
to.
all right. We can hear you, though.
Okay. There we go. My name is Julia with CBS News. Thank you so much for hosting this. How does this technology come at a cost to consumers? Because it seems right now in the aviation industry that a lot of consumers are concerned about pricing, increasing prices, and it seems that a lot of airlines are downgrading and making spaces smaller. I think a couple of days ago I saw that airplanes were trying to put seats backwards and things like that. So I was just wondering, how does this affect the consumer in terms of pricing?
I'm gonna defer to somebody else after I give it a guess. Okay, I think one of the things is I think you will find a great benefit to the consumer, because again, as I said, shorter transit times, more competition actually when you get there, and there's nothing like competition to drive the price down. So I see those kinds of things working. I don't think the general aviation consumer will see any effect just yet, because this is a government industry partnership where we're putting up a significant portion of the expense. So they've already paid for that in their taxpayer dollars. And what we're trying to do is actually put the taxpayers' dollars to work in the most efficient and effective manner that we can find. for them. So I think in the long term, it's going to be a great benefit to the consumer. I don't know whether anybody else wants to.
Yeah, just one quick point. One of the reasons why airlines are getting really stingy on everything is because their fuel cost takes up about nominally one third of their total operating cost. That's sort of on the average, industry-wide average. So that's a huge cost item for airlines. That's why many of these concepts, we're going after 50% or more of a fuel consumption reduction. So by the time we actually implement these technologies in industries that our strong U.S. industry is turning into these concepts and technologies to product and actually save 50% or more fuel consumption, I think our airlines will return some of those profits back to flying public.
Zach Rosenberg, Air and Space Magazine. First question is for Dr. Shin. You're surrounded by a number of concepts, illustrations, and models. I'm wondering why this is the concept that you guys decided to unveil today and what the timeline is for speaking about the rest of them. Second question is for General Bolden. General, can you just elaborate a little bit on what made the difference in between the FY16 and FY17 requests for aeronautics?
Development and introduction into actual market in the aviation business, it takes some time. So some people say about 15 years or 20 years, somewhere between there. The reason why is, again, it's a really high-tech industry and fairly capital-intensive industry. So, and then safety is paramount. So you don't do anything to jeopardize safety. So when you put all those factors in, it takes a fairly long time. So that's one of the reasons why public-private partnership for the country is so critically important, that NASA Aeronautics does technologies for 15, 20 years out. So we are not working on any near-term technologies, while our U.S. aviation industry is doing great job in leading the global market, aviation market. Government can make a smart investment to work on next generation technologies. So when industry sees the market opportunity based on their business case and business models, then those promising technologies are ready for industry to take on. So that's our strategy, and it has been worked out very well.
Do you have a timeline for announcing the development of any of these other technologies that are on the back of there?
Well, we can only talk about what NASA can actually do. So we are trying to, with the full funding that President requested, that we can actually do several flight demonstrators and design and build and start flying during early 2020 timeframe. And then that's anywhere between 10 and 15 years out. And then we will continue to work with U.S. industry to introduce these benefits and technologies. And then you can guess, depending on the market condition, U.S. companies will decide when to enter the market.
And in response to the second part of your question, patience and persistence. The question was, what's the difference between the 2016 budget and the 2017 budget levels? It is the result of knowing that you can't go for everything all at once, and the fact that you've got to be able to demonstrate to people that when you make a promise, you're going to deliver. You're going to deliver hopefully on time and on cost. And I think Jaiwon mentioned we rolled out the new strategic plan for aeronautics in 2013, and we started talking about the plan that we wanted to put in place. David Melcher talked about industry being willing to follow as long as there is a concrete plan in place with details that people who are pretty sharp can follow, because they don't want to throw away good money after bad. And it just took us the time to get there. And probably the biggest thing was, I'm an aviator, I'm a pilot. And so I came to NASA to try to reinstill some vigor into the Aeronautics Mission Directorate. But every year, my first few years, you've got to prioritize stuff. And so aeronautics just always stayed right at the same level it was. And then when I started going in, talking to Congress more and more, they said, hey, you didn't ask for it. So I said, oh, okay, if that's all I got to do, I can handle that. And it sounds trivial, but we made a very conscious decision, and we talked to the leadership of the agency, and we said, look, this agency has led the nation for 100 years. First as NACA and now as NASA. We have made the nation #1 in the field of aeronautics. You know, when the Wright brothers invented the airplane, America walked away from airplanes for about 15 years. NACA came about in 1915 because the Wright brothers could not get an American company to buy an airplane. They couldn't get the U.S. Army Air Corps to buy an airplane. And the Europeans started building airplanes and improving on the airplane, and we woke up. It took us 12 years to wake up, and NACA was formed just as NASA was formed to transition NACA to space when we were awakened by something that threatened our leadership. We just don't want to find ourselves there again, and so we decided that the best thing for NASA to do was exert its leadership and its influence. I consider myself to be the President and the Congress's #1 advisor on civil aeronautics and space. They may not look at me that way, but I've got some incredibly brilliant engineers and scientists and people who advise me to advise the President and the Congress. And we generally think when we thought something through and we take it to them, if they choose to follow us, we're going to end up in pretty good shape. So this was a long time in coming. This is, we started this back in 2013, and that's what makes today such a big day. My hat's off to the folk in aeronautics for being patient and, allowing me to be patient and learn. Thank you.
We're going to have to come to a close here pretty soon, so maybe one more question. I do have several folks here that can give you more details once we officially end. So, anyone else?
Hi, Mark Sellinger, Aerospace America again. Can you explain how this quest will achieve the low boom without getting too technical? And is it certain features of the design, and also how it compares to previous efforts to achieve supersonic, including the Concorde, which I know wasn't that quiet, and some U.S. efforts as well. Thank you.
Go into that when you go down? Or you want
Yeah, I can just really give you a quick answer, but this is a great segue. If you all come down, I think it's downstairs, we're going to have another hour of really detailed Q&A session, so we can better answer that during next session. But very quickly, again, I emphasize the design. So you see the long and very pointy nose. So that will that's the design feature for this low boom supersonic airplane. And years of research revealed or taught us that you have to have a slender and long nose, but it presents a lot of challenges. So we have overcome a lot of our technical challenges to fly that type of shape of aircraft. So let me just give you that as a teaser. And in the next hour or so, please come join us and learn more about what we mean by 5 demonstrators or 6 demonstrators and what we're trying to do over the next 10 years.
Appreciate it, Charlie. And that's going to do it for our news conference today. I'd like to thank our panelists, Charlie, Jaiwon, and David, for joining us today. I have a colleague over here that has press kits for the media. Any that we have remaining after the media get their copy of it, then we can give it to other people. If you'd like more information about this, about NASA aeronautics programs, join us on the web at www.nasa.gov/aeronautics. And for more information about any of NASA's various programs and projects, you can join us at www.nasa.gov or among any of our many social media products. And with that, thanks for joining us today. Have a great day.